Good morning everyone in grade 7. This is teacher Manal Abdelhadi with you from Maria School. You make me happy when you make your homework, so please keep it up. Now this is the third lesson in our unit Magnetic Field Patterns. Our outcomes: explaining the magnetic field, drawing magnetic field for a bar magnet, describing the magnetic field of Earth, and we are going to use thinking skills strategy. So welcome. Let's start. We will talk now about magnetic field. So magnet is surrounded by a magnetic field. Any magnetic material placed around it or in the field will be attracted by the magnet, as this screw you can see here. It is attracted by the magnet from a distance. So everywhere around the magnet, if you put it, it will be attracted again, because the area around or the region around it is affected by the magnetic force, and this area or this region here around it, we call it magnetic field. Let's see the definition now. Magnetic field: a region where there is a force on a magnet or a piece of magnetic material. So a region where there is a force on a magnet. It could affect on another magnet. We can remember that there is repulsion forces between north and south. There's attraction forces between north and south poles. So on this piece or in a piece of magnetic material, so it could only attract other magnetic materials, or it can attract other magnets, and that's the region affecting the force, magnetic force affecting on. This is important now. Magnetic field lines. Now we knew that the area around or the region around the magnet is a magnetic field. Now the magnetic field, it means that this magnet can attract or affect on other magnets and magnetic materials from a distance. Okay, so that because of that it is called magnetic field. Like the magnetic or the gravity field, like the gravity field of Earth. So the magnetic field lines are lines which shows the direction and strength of a magnetic field. It shows two things: direction and strength of a magnetic field. So let's see this magnet. We have a north pole and we have a south pole. This is the lines. This curved lines is going upward, and you can see that by looking at the arrows. And this line is going downward. So that's the direction of the magnetic field lines. All the lines is going away from the north, and all the lines is going towards the south, as you can see here. So the lines on these curved lines is going from north to south poles. That's the main direction for all the lines. And the lines, they are concentrated on the poles. As you can see, we have more lines here than the lines in the middle. So in the poles, the lines concentrated. It means that the magnetic field is stronger, or is stronger in the poles. We have a classwork now. Open your notebook with me and write the rules and draw the magnetic field lines on your notebook. Okay, your notebook, please. So, rules for drawing magnetic fields correctly. The field lines have arrows on them. As you can see here, all the arrows is drawn on the curved and on the straight lines. Now second, the field lines come out of N, North Pole, and go into S, South Pole. So all the lines here coming out of north towards south, coming out of north towards south, and the lines or the curves and the edges, they are going just outward of north and towards south. Another rule: the field lines are more concentrated at the poles. So you have more lines or more curves coming in the edges or the poles. But what about the middle? We have less concentrated lines. Last rule: magnetic field lines do not cross each other, so they are not intersecting. They are not making letter X. When you finish now writing and drawing, you have to write these rules on your notebook, and you have to draw this figure on your notebook also. Send a photo for me so I can be sure that you did your classwork. Let's answer this question in our course book, page 166, question 1. Look at the diagram of the field lines around a bar magnet. Where is the field strongest? Explain how you can tell. So, where is the area the field is strongest? This one or that one? Okay, the field is strongest on the poles, and it is weakest in the middle. It is weakest in the middle. Why? Let's see. Field is strongest at poles of magnet where the lines are closest together. Closest together or concentrated together. Because of that, it is strongest. As you can see in this bar magnet, the magnetic field is invisible. We can't see it around. So to show up its shape, we have two ways. This is the first one.
Begin by placing the clear plastic or glass over a magnet. In this case, I use the cover of an old takeout tray. Carefully shake the iron filings out over the magnet and clear cover. You'll notice that as you shake, the filings will begin to arrange themselves almost magically across distinct lines. This is a result of the north and south poles of each shavings arranging themselves with the magnetic field. When done shaking, make sure kids observe the pattern both overhead and from the side. From the side, they'll observe that the field is three-dimensional, meaning the magnetic field extends in all directions from the North Pole and wraps back around to the South Pole.
So this is the first method. He used iron filings. Like he spread them above a plastic shield, above the magnet, and they distributed like this way. They show us that there is a magnetic field around. And they like show us even the lines and where the magnetic field's concentrated in. Let's see the other method. In this method, we are using small compasses called plotting compasses. Why plotting compasses? Because they are going to plot or to draw, to show us the magnetic field lines or the path of the magnetic field lines. Like this compass here, if we put it in anywhere here, it can show us the line and we can just follow the line to draw it. If we put it here in this direction, it will show us like the direction to the left, and here also it's to the left. If we put the compass in this direction, it's gonna be to the left side. If we put the compass in this point, for example, it will show us the way it is to the right side, and like if we follow this path, it will show us that it's gonna like end in the South Pole. Let's solve question 2 in the same page 166. Compare the diagram of a field lines with the photograph. In what way are they similar? So that's the bar magnet, and this is the curves or the magnetic field lines, and this is the photograph we are talking about. There is iron filings here. So the iron filings form up into lines. They, as you can see, they show us like here straight lines and here curved lines, and which have the same curved shape as the field lines. So iron fillings form up into lines which have the same curved shape as this here, same curved shape as the field lines. Closest together near poles. They are closest together near South Pole and North Pole as this field lines here. The last point in our lesson, the magnetic earth. Please concentrate here. I don't want that to be a source of misunderstanding. So here, Earth has a magnetic field, as if there were giant magnetic or magnet inside. As if there is a giant magnet inside. As you can see here, we have a giant magnet, and there's the South Pole and North Pole of this magnet. Now, a compass needle will point towards the North Pole. The compass needle here, the red part, will point to the North Pole, which is the Arctic near the geographic North Pole. Okay, so the compass will point towards the geometric North Pole, we call that. But why the magnet of Earth is opposite? So we have a South Pole or South Magnetic Pole towards the North Geometric Pole, and the North magnetic pole of Earth is toward the south geometric poles. South and north geometric poles, they are already on the maps. They are used in the maps, but we don't use the south and north magnets of the Earth on maps. But why do we have south magnetic pole of Earth towards the north geometric pole? Now when it comes to magnets, opposite attracts. So this fact means that the north end of a magnet in a compass is attracted to the south. So that's the north attracted to the south. Let me say that again. When it comes to magnets, opposite attract. So this fact means that the north end of a magnet in a compass is attracted to the south magnet pole, which lies close to the geometric north pole. So this one, south magnetic pole, actually lies close to the geometric north pole. Okay? And now you know that the magnetic field lines outside of a permanent magnet always runs from north magnetic pole towards the south magnetic pole. So we can see these lines going out of north magnetic pole towards the south magnetic pole of the Earth. So the north and south geometric poles are totally opposite than the magnetic of Earth. And we said that the reason, because the north pole of the compass should attract to the opposite, so it should attract to the south magnetic pole, which is towards or close to the north geometric pole. Let's see next. Question 3, page 167. Explain why the imaginary magnet inside the Earth is shown with the south pole at the top, between brackets here, the north end. So why do we have a south magnetic pole towards the north geometric pole? So that's the answer now. The north pole of a compass needle is attracted to the Earth's magnetic north. Again, the north pole of a compass needle, that's the north pole, the red part of the compass, is attracted to the Earth's magnetic pole. It should be attracted to the opposite pole. So this one is north, it should attract to south. So north and south are next to each other. Okay, so that must be the south pole there, because opposite poles attract. This mind map can help you to understand things about magnets from the previous lesson and this lesson. Highlight these 2 pages in your book now, page 166, and put these notes. The fields is the weakest, in the middle, and on the poles, field is the strongest. We already answered question number 1, 2, 3. I hope you wrote the answers. And please don't forget also this note and the summary. They are all important. At last, this is your homework workbook, page 124, 125. Don't forget to ask Allah for good health. This is the dua of Prophet Ibrahim. أعوذ بالله من الشيطان الرجيم وإذا مرضت فهو يشفين. So ask Allah all the time to protect you and your family. Hope you the best. Take care. Thank you.